Alright, you guys. So before we begin, I just want to show you this new course that I've created, coding a C compiler in JavaScript. So you will learn lexing and grammar and ASTs, parsing, code generation. So check out the link up top on your screen, or you can find a really good offer inside of the video description. So let's begin today's episode. Sup guys, welcome to today's show. So last time we created the mount function and unmount function as well as the show function. So today we are going to start dealing with the files, or more specifically the inodes. We're going to create and destroy, we're going to load and save. Okay, so let's start with the signatures. So we're going to need the inode create, and what should this return? I guess the easiest way would be to return an inode pointer to the actual structure. For now this will be an internal function, and in order to create an inode of size 0, what do we need? We need a file name, at least if it's a file. Well, if it's a directory too, I guess. So a file name pointer. We need a file system, of course. Let's see how an inode structure looks. Well, we need to decide if it's a directory or what it is. So maybe we shouldn't make this anonymous. Internal packed enum. Let's give it a name. Type. So this will be type def enum type. And let's call this type. So we need the type as well. And that's all we need. And we also need the destroy, and maybe this can return a boolean. Inode destroy. And all we really need is the inode number, so a pointer. And maybe we should return the inode number here instead. Since it's not inside of the inode structure, it's easier that way. And what else did I say? We need the alloc and
unalloc. So inode alloc, and this is going to return pointer to our allocated inode. And we don't need any argument besides the file system, I guess. And then we can have an internal void inode unalloc, which only takes in the pointer. Okay, so let's start with, since we are going to need those two when we do these two, let's start with the allocation function. So internal pointer inode alloc, and we only need the file system. So file system fs. If we don't have an fs, we will return. How do we signal an error? Because 0 is a valid, well, it's not actually, because the 0 is always the root directory. We should never have to alloc that, since it's created when we format. So 0 can be the error. That's good. And we need to have a pointer, and this is the index, let's say. And we need to iterate through all the possible inodes. So int16n until we find someone that is not valid. So for n is equal to 0, while n is less than fs metadata inodes n++. So let's create the pointer p. Let's set p equal to, and what did we call that function? Find inode fs, and it takes an index, which is our n at this point. And if this returns an error, we have probably gone too far, so let's break. Otherwise, we're going to check if the P valid type, and not just that, but this ANDed with a 1, so we get the least significant bit. So if this is not valid, that is what we're looking for, right? Let's also set the index to 0 at start. And if we find this thing, in that case, we want to set the index equal to n and break. Down here, if we have a P, we want to free that P, so we don't leak a lot of memory. And then we can just return our index, which is either 0 if it failed, or it has a value. And we should also allocate it, by the way. So how do we do that? Well, we set the P valid type we do only want to set the least significant bit. So it should be equal to 1, right? Yeah, let's do that. And where else do we need to update things? Inside of the super block, we need to increase the total number of inodes. So let's create an FS block. And in this case, we want to first read in the current, or can we rely on our file file system structures copy of the superblock that it is up to date? I think we can, because nothing else should be editing that part of the disk. So that will make things a little bit easier. Then we can just take the FS metadata inodes and increase this. And then we write the superblock to disk. So disk write, and this is going to be our FSDD. The address is going to be the address of the FS metadata. And the block is 1. And we don't care about the return value. And I guess that's it. So how do we unallocate? We'll have a internal void inode unalloc, and it takes in a pointer. inode. Let's just double check the signature. Yes. Well, it needs the file system, doesn't it? Okay, so how do we unallocate? Well, we need to find that thing first. So let's create an inode p. P is equal to find inode of fs and our inode. Maybe we should be consequential and call this an index. Let's also check that we do have an fs. Otherwise we return false. No, we can't return anything. We'll just return. Maybe we should make this a bool actually, because we need to know if this fails or not. Otherwise we will be leaking inodes on the disk. So let's return false here. And if we don't have a p, same thing. if we do have a P, we want to change this P valid type to 0. Well, it's not enough just to set this P valid type to 1 here. We'd need to write that block as well. That's a little bit annoying. Because we don't know which block that is. We know the pointer. We know the inode number. And we know how many inodes there are per block. So let's see. If we have, let's say the block is 5, or yes, the block is 5. And how many inodes per block do we have? 16. So let's say our inode is 84. If we divide 84 by 16, then we know what block it is. What if it can't be the first block, but what if it's well, it's the first inode block. But let's say this is inode 5, then we return 0. Which means the first inode block. And the first inode block is 2. So we need to add 2 to whatever the result is. Right. But what about the 5 we had? That's the 5th inode block. Isn't that the 6th block? If we have inode 17, that is the first inode block, which is block 2. My head is spinning right now. Well, if we divide and add 1, then we have the number of inode blocks. And if we add another 1, we have the actual block number. Yeah, we need to add 2 to it. So let's create a pointer block number. Well, we need this function, don't we? fs save inode. And we should do these kind of calculations inside of there. So let's develop this function first. So let's see, fs save inode. This can return block number written. And it takes a file system, and it takes a pointer to an inode we want to write, and it takes an inode number. Right. So let's also check, by the way, that we have an inode. And an index which is not 0. Well, it could be inode 0 actually. Maybe we don't need this. Alright, so the block number is going to be equal to the inode number divided by 16 plus 2. That is the block number containing our inode. So when we know the block, we can write this thing. Well, we need to read in that block first. Let's see. Let's create an FS block. And let's do a read. And we provide the fsdd. The address is going to be the address to our block inodes or data, maybe. Block size. No, we need a block number. So now we have that block. Now we need to update that block in memory with the inode that we have in memory. Which means we need to memcopy into the address of the block dot inodes at index. And we will copy from the inode that is provided. We need a size. Which is the size of a struct S inode. Okay, so now we can write that block. By the way, if this fails, we should fail. And we set ret equal to d write, and we're going to write fsdd, and the address is the block data again at the block number. If this fails, return 0. Otherwise, we just return the block number written. Okay, easy enough. So now that we have updated our P, we can do fs write inode, takes in our fs, and this is our P, and this is our index. So this will write the block, and maybe we should do a check as well. If this returns 0, we don't need to update the super block. So in that case, let's just set index to 0 again and break. Otherwise we write the super block and we break. And then we return the index. And the unalloc will be pretty similar. Set the valid type to 0 and we write that block. So we'll do an fs save inode, fs p and index. And this will return a block number. We can free our p, and then we return if the block number is positive, we can return true, otherwise false. I guess that's it. Maybe we should try this out before we continue. So maybe we can cheat a little bit, and by the end of our mount function we can run some things. So let's say we allocate one let's see, we do an inode alloc of our file system, maybe even 2. And then we do an fs show of our fs, and let's not show the bn. And that's it. So let's try to compile this. memcpu 384. It should be copy. Warning, value computed is not used. That shouldn't really annoying warning. What if we do this? Unused variable block number 396. But do we get a linking error? Undefined reference to FS save inode. Did I forget to create the signature? Oh, wait a second, write inode. Let's name this FS save inode. Do we have any more write inode? Yes. Okay. So let's see what happens. It does only print this inode, so either it failed to allocate it, or it's not printing correctly. So let's do a hex dump of our disk. And let's see if we can interpret anything. So this is the first inode right here, and this is the only one we have. Something did not work. Let's see if we can get a return value from this thing. Zero. So something fails. Before we start checking our code, let's do an strace of this. Let's just take the last 100 things. It's trying to write to a negative block. No? 512. Yes, maybe it tries to do that. So why does that happen? alloc. So IDX is the inode number, and we provide this to fsave inode. Take the IDX, we divide it by 16. Which might be 0 plus 2. So the block number should be 2. Let's check. Block number equal to this. It does not even print this. So it does not call fsave inode. We shouldn't just scan the inodes that exist. We need to scan all possible inodes. Which is the inode blocks times the number of inodes per block. So let's say we have a max. Our max is equal to the fs metadata inode blocks times inodes per block. So this is the number of inodes that can be there. So while n is less than or equal to max, all right, let's try this again. Okay, this looks more like it. Block number equal to 2, TMP is 1. Block number equal to 2, TMP is 2. And now we have 2 inodes of type file. Cool. And if we run this again, now I have 4. Let's see what happens when it's supposed to change block. Then it crashes. Why though? Block number is equal to 3. That must be a bug inside of our find inode function, right? So this seems to work when we are at the first inode block, but when it's supposed to go to the next, something doesn't work. So y is less than inodes per block. And this is one thing which is wrong, but I don't think this has to do with the error. We should go further than inode blocks. Since we start at block number 2, so number 2 is the first inode block. I think we should have +1 here. Maybe even 2. Alright, so we zero out the block. We read the block X. Before we compile this, let's do an strace. So we try to write the third block. And then it crashes. Either this crashes, but I think something else does. I want to see what function this occurs in. So let's go into tmp command. Well, it didn't give us a whole lot of information. But what if we break at the well, it's our inode alloc that fails. So let's go there. Right, so here we are. Let's step I and do that until we crash. Alright, so find inode. So this is the last thing, or this rather. (207) add ESP10 test EX. Well, let's break at this position. Delete breakpoints, yes, and we break here. Well, that's a stack address, isn't it? So where is this? This is our inalloc, and 207 is plus 55. So delete breakpoints, yes. Let's do start, yes. Disassemble inalloc. And plus 55 is this add instruction, so let's break there, continue. Okay, so now we're here. Let's step I until we crash. Okay, so it's not the first time we run this. Let's do this instead. We delete breakpoints, yes. We start, yes. We break in inalloc. Continue. And we count how many times before it crashes. So here we're at 1. Okay, it crashes in the first run of the inalloc. Well, let's do this then. Break at this address, continue, and then we do step I until we crash. Wish it were some easier way of doing this. There probably is. Because I want to step instruction by instruction without stepping into any functions. And I don't want to alternate between different commands. I want to be able to just type one command and push enter like I do now. But something better than step I. If you know of any good way, please type it in the comment. What if I just continue? Well, at least we know it has something to do with this find inode thing. So let's try to look at this critically. We start at 2, so that's a block number. And we go through the different inode blocks. And I don't think this returns 0, because then our thing would return 0, right? So it tries to do this. We're trying to reach index 16. So this it's going to do 16 times. So if n is equal to 16, when this has run its first 16 rounds, n will be equal to 15. Then we should read in the next block. Where is that find inode? Here. Well, we need to do something. Let's print our x and y variables at least, so we know a little bit more specific when it's going to happen. The crash, that is. So y is equal to 15, x is equal to 3, then when y is equal to 0, then something here crashes. It would be interesting to know the value of n as well. So n is equal to 16. Maybe we are at the wrong place, because this terminates the function when it finds the right thing, and then it prints block number is equal to 3. That's from this, I think, or one of our other functions. Okay, so it's our save inode. So block number is 3. So we try to read from block number 3. And then we try to copy into the inodes at index. Wait a second. Our index is our index is 16, so we go past that. So I guess we need to have a modulus. So let's say we have a pointer which is our modulus. So the mod is equal to idx mod 16. Because we do want to index into this thing, but when we get to 16, we want to start over from 0. So that's what we want to put here. Okay, that makes sense. Okay, that's more like it. Oh, it's so nice when we solve a tricky problem like that. So let's clean this up a little bit. We have this, and then we have the other function up here somewhere. Find inode. Let's remove this and this and this. And inside of our mount is it? We don't need to print this. Okay, so that works fine. If we were to do a hex dump, how would that look? So here is one inode. And here's one. Well, everything works. So we can check off our alloc, unalloc, fs save inode. And these creating and destroying should be pretty simple now that we have those helper functions. So we will continue right after this. What's up, guys? Welcome back. So now that we have some helper functions, creating and destroying inodes should be pretty simple, I think. So let's get on with it. So the signature of the first function is it takes a file system, a file name, a type, and it provides a pointer, which is a let's see, it's an inode number in this case. Alright, so let's go. So we have an internal pointer, inode create, which will take in a file system FS and a file name name and a type. Let's call it file type. Alright, and we need at least one pointer since we'll be returning it, so let's call this the index like before. And if we don't have a file system, or we don't have a file name, or our file type is 0, then we will return an error. So we're gonna need let's see, this returns the pointer. So we're also gonna need one inode. And let's make our lives a little bit easier by copying the inode struct. So as usual, we will put this inside of a comment. Like so. Alright, so let's start by allocating the inode. So our IDX will be equal to inode alloc, and it will only take the file system. If we don't get something back, we can safely return an error. Otherwise, we have allocated an inode, and we now have an empty one inside our file system. But we need to find the structure for it, so we'll do find inode, file system, and the index. And if we don't get anything back, we can return 0. Otherwise, we have this inode. So let's start by putting in the valid type field, and we'll set it to our file type. Then we need to copy the file name. By the way, we should check that the file name is valid. Or maybe we do that before we even use this function. Maybe we should at least check that it doesn't contain any weird characters. Let's say we have a bool OK or valid. And we can do this up here. So valid is equal to some function which we need to create. Valid file name or valid fname, and it takes in the name, and it also needs to know the file type, since directories will be handled a little bit differently. So let's create this function as an empty function for now. So it will return a bool. Valid file name takes in a file system, no, file name, and a type. By the way, most of these functions should probably not be internal but private. Maybe we need to make a mental note about that. So bool valid fname, and we'll have a file name and a type, file type. And for now, this will just return true. Let's also highlight this so we don't forget. And if you want to know how I make these red things here, this is a bookmark. So you need to download an extension which is called bookmark something, and then you need to define in your configuration file for VS Code, the JSON file, a background for this. Alright, so if valid is false, we will also return 0. Maybe, by the way, and this was a private. Maybe we should actually provide some error handling here. We need to set the error number to no error. And in this case, return error bad argument. So let's make a small list here of the things we want to add, because it will probably be a couple of different errors. So it will be error bad argument. And we can remove this thing here. And if the file name is not valid, return error bad file name. maybe we don't need, maybe we can just say this is an argument error and this is a file name error. And in this case, it's not really clear. The best way would be to propagate the error from this function. So let's go to look, I'm not going to do that now, but I want to remind myself about it. Errors. So in this way, we just want to send the same error. So let's say we have a throw function, which does just that. Where do we put this? I guess a good way would be the same place that we have the error number. I think that's in our OS actually. No? Maybe it is OmniSTD. Where did we put that error handling? Here we have the return. Oh, it's called error number. Alright. So in this case, for now at least, the only thing we need to do with our throw is maybe we can just do return 0 because the error number is already set. That's good enough, I think. Let's keep this open here because we need to add the errors later. Sorry, my phone is buzzing and I can't reach it right now. Alright, so let's see, where were we? Here. So we will throw, and this will be a semi-keyword, so no function parameters. And if we don't find the inode, maybe we can have something like, we can do this, return error bad inode, and we do the same here. But I will still keep that. No, not this. I will still keep the throw function though, because we are going to use it later. Error inode. So we have file name, argument errors, and we have error inode. And we'll add them right here. Okay, so maybe we can move this down a bit. Okay, so that's the file type field. Then we have the size, and that should be 0, because it always starts 0. The file name we need to copy, so we can just do a simple copy. We don't have to format it in any way. So into the inode name field, we're going to copy our name, and we need the size though. So the size is going to be size of struct s file name. And the rest we'll leave as it is. Maybe we can well, when we do the find inode, I think it is 0. But no, we're not sure about that, since this could be a reused old inode, actually. Which just reminds me... No, never mind. So let's zero it out to be sure. Maybe we don't even need to find it, do we? What's the signature for our save inode thing? Takes an inode, but we could leave that as 0. I think we're gonna do that. So the inode can be a new allocation. We'll set the size equal to size of struct s inode. We set inode equal to inode alloc size. If we don't have an inode, we will return the error of no memory. So now we can remove this. And that's pretty much it, I think. We need to save it though. So we can reuse this valid thing. FS save inode. We have the file system, we have the inode, and we have the index. And what does it return? It returns the written block. So in this case we want to free our inode. Let's use the correct function, free our inode, and then we can return the error of error IO. And otherwise, if we get down to this point, we can still free our inode. So maybe we move this up here. And we'll return the index. Easy as pie. So that was the creation of the inode. How do we remove one? So destroy. It returns a boolean and it takes in a pointer. And we have an inode unalloc. Will there be any difference between inode destroy and inode unalloc? Don't think so. Maybe we don't even need a function. Let's just do an alias, a macro. So inode unalloc takes a file system and a pointer, and it just calls no, this is the name we have. It should be inode destroy, and it should return a boolean, so we'll make it a boolean. And we will call inode unalloc, provide the file system, we provide the pointer. So now we can just remove this ion destroy thing. And we are done with that as well. And fstat, I have not really decided how we're going to do with it. But for now, let's just make it return the size. Probably there'll be more info later on. So let's make it in such a way that we can extend it easily. We'll have an internal structure. Let's call this something like fs info. that a good name? File info maybe. And for now, the only thing we're gonna have is an int16 size. And maybe the inode number. And this is going to be packed. So then we type def our struct s file info, and this will just be file info. Why is this green here? And this is white. All the other ones are white. That's usually not a good sign. Well, the compiler would probably tell us. It can be a bug in VS Code as well. Alright, so let's say this is what exactly? I'm pretty sure this is going to be public, by the way, so let's make it so. And it's gonna return, well, one of those file info structures, fs stat, and what is it going to take? A file name would be the most logical thing, right? That is how, I mean a full path name actually. Yeah. So it will just take an int 8 basically. Maybe a file system. No, because it can start with C colon or D colon or whatever. Maybe we can define its own type path. And I will just type def the path as int 8. But we haven't really made all the functions necessary to find this path. So maybe we can do this for now. And let it take a pointer to an inode. So an inode number. And we'll change this later on. A lot of postpone work, right? So this will be, let's make a comment by the way. Change to, we can do this. We can give the both signatures. So public file info fs stat, and this will take a path. comment this out and highlight it, and then we'll do the other one. So public file info fs stat, and this will be the pointer instead. And at this point, the pointer should be able to be 0, because we should be able to do an fstat on the root directory, I think. But we do need the file system if we just have a pointer. File system fs pointer index. So if we don't have an fs, we should return the error of argument error. Right. So let's see. We want to have an inode like so. An inode would be equal to find inode of the file system and the index. And if we don't have an inode and no. What does the find inode do if we give it a 0 as the index? Seems to handle that. Okay, good. Okay, so if we don't have an inode, we can return an error. And what do we do up here? Error inode, that's a good one. Otherwise, we can allocate our file infrastructure. So file info, and we need a size as well. The size is equal to the size of a struct s file info. And then we just allocate as usual. Let's zero this thing out. And set the respective fields. So info idx will be idx. Info size will be inode size. And now we can free the inode. We can return the info. And maybe we can set this x in parentheses. Yeah, let's do that. All right, let's see if we can get this code to compile then. Um, 303 TMP. We don't need to allocate any more of these. What else? Are no undeclared 463. Oh, this should be our number. Four 997. Yes, that star is malplaced. Conflicting types. Public file info FS data pointer. Right, we added the file system. Huh? 496. 496. Oh. There we go. Declared static but never defined. Valid F name. I think I defined that. Valid F name. Ah, it's a dispute still. Okay, never mind that. Alright, we'll be right back after this. Alright, welcome back you guys. So before the break, we finished a lot of these inode creating functions, like inode create, destroy, find inode, and the allocation and unallocation functions, as well as our save inode and fstat. But we haven't really tried them out yet, so let's see if they work. And to make this a little bit easier on ourselves, I'm gonna modify this mounting function like I did before. So let's see how we're gonna do this. We know that our IN alloc and unalloc works because those we have tried, at least the allocation function. Save inode should work as well, so we need to try out our IN create. So it takes a file system, a file name, and a type, and returns a pointer to an inode. So we can use the IDX. Let's say IDX is equal to inode create, and we give them this the fs, and we need a file name. So let's say autoexec.bat, and we need to provide this as an int8 string. So let's cast this, and the last argument is the file type. So this will be type file in this case. Let's also, well, let's print the result of this first. So IDX equal to this IDX, and this should be cast as a regular integer. And let's do this again. And this time, let's see if we can create a directory. So let's, for instance, create an MS-DOS directory, or not MS-DOS, let's do DDOS. And this should be a type directory. And we print the result, and then we do an fs show to show all the different inodes on the system. Right? So let's compile this thing. Right, we should not provide a string as the file name. That is right. We need to create an actual file structure. So let's do that. File name, name, say. So let's start by zeroing out this thing. We need to know its size as well. So let's reuse the size variable that we already have. So size is equal to the size of a struct s file name. So then we zero this out like so. So how do we copy something into it? We need to use the string copy function that I made. So string copy into the, let's see. First of all, we need to cast this as an int8. Then we take the address of the name.name. And we copy from the static string autoexec. And we need to give this a length, so this is 8 bytes. And then we need to do the same procedure for the extension, which in this case is bot, and this is 3 bytes. But maybe we should do a regular mem copy and not a string copy, because we don't want to add the null terminator. Let's see how that works, by the way. If string, and this is not equal to 0, so we need to have something like if string, then we want to add the null terminator. So this will just be the destination pointer is equal to 0, or we need to cast this into an int 8 0. Alright, so now we can give the address of name. So let's remove this, and we copied this whole thing, put it here, and in this case we will not have an extension. We'll just call this DDOS, and these are 4 bytes. And maybe we can even do a string copy in this case, and since we should be able to add the null terminator without a problem when it's only 4 bytes. And this should be a directory. Alright, let's see if this works. Compile at least, but why does it say it's never defined? Valid f name. Valid f name. It's a private function. And same here. Valid f name. Valid f name. So why does it complain? That's pretty weird, right? Is it because we have not used it, but we have that as well? Well, let's try it and see what happens. So all we need to do is run our command.com like so, and we scroll up a bit. Okay, so it succeeded in both cases and created an inode with ID 20 and one with 21. So by the end of all this, we should find name is autoexec, name is DDoS, but we don't see the extension. We do not see the extension. Let's see. We do copy it into the extension field at least. So it must be the show function that doesn't do it properly. So let's see how it prints the file name. Name is this. File to string inode name. Inode name. Yes, inode name. So let's see that file to string function. File to string. File to string. File to string. Here it is. So if the extension's first character is 0, we just return f name name. Otherwise, what do? Zero out our buffer. We can't do this, by the way, because if it's an 8-character name, it will be trouble. Here we do a string copy. Maybe we should do a regular copy. Into the buff. From the name, 8 bytes at most. And then we do a string len. Okay, that's probably the problem. Because we do need to add the null terminator. So maybe we should do, no, we can't do that. What we can do is we can check the 8th byte and see if that is a 0 of the input variable. So if fname name, and we want the index 7, if that is 0, or rather if that is not 0, then we want to add the null terminator. So if it's not 0, That means it fills up the entire 8 bytes. Maybe we can do something like this. So if it's not 0, then we can set n equal to 8. Let's see. Otherwise, we can set n equal to the string length, because then there will be a null terminator. I don't think we should increase it here, though. Well, we can actually do this anyway, because we have copied it to buff, and buff has more room than this. So we can set n equal to the string length of buff. And then if it's 8 characters, we want to use index 8 and set the dot. Then we increase n. P is equal to buff plus n. And then we do a regular copy of the extension. So let's see. And then we need to add the null terminator again. Or actually we don't. I think this is okay. The problem was probably that we increased n when we shouldn't. However, we still need to check the extension. So if we copy this thing, so let's see, before we add the dot, that will be here. So if the extension is 0, then we are satisfied with the buff as it is. So we'll set p to buff and we'll return p. Otherwise, we do the string length, add the dot, copy the extension, and we're done. Alright, I think this is going to work. So, Let's comment out, or we can actually remove all of this. So let's do this. Mm-hmm. 276. Okay, this should. It should not be here, but what did it complain about? This if clause does not guard, okay. Okay. 290. Right, this should be 2 there. Unused variable name. That's true. Alright, let's see what it says. Autoexec bot. Very nice. Okay, so that works. What else do we have? Ion destroy. We do have a lot of garbage files here, so let's destroy everything from inode 1 to 19, say. So let's do something like for size is equal to 1 and is less, no, size is less than 19, size plus plus, and I reused this size because I didn't have any other suitable integer. So what we're going to do is we're going to fs inode destroy, and we need an fs and we need a pointer. And now we only have these. What happens if we were to allocate a new one? Will it reuse the inode 1, for instance? Let's remove this and let's do inode alloc-fs. Yes, now we have inode 1 again. Perfect. Very nice. So the only thing we haven't checked is if our fstat works. Let's give this autoexec bot file a size. So inode 20. Do we have need to have an inode structure, so ino, and we'll set ino equal to find inode fs20, and we'll set the inode size equal to, I don't know, 300. And then we need to write this. So fs save inode, fs and inode and 20. And then we can set the size equal to fs stat. It takes an fs and it takes a pointer. And let's print this. So size equal this. By the way, it does not return a size, it returns an info structure. fs info, I think it's called. Or is it inode info? File info. So we print the file size, so fi size. We free the fi, and then we fs show. So if everything works, it should print size 200 or whatever it was. Size is 300. So that works too. All of these functions work. And we have almost written all of the functions for the entire file system API. The only thing left actually is reading and writing file data. And then open directory and open file and everything that has to do with like path names and such. And that we will do in the next episode. So if you like this episode, please like and subscribe. And thank you for watching, and thanks for today.